Hi, today we're looking at Pat 2012 and going through questions 13 to 16. These are 4 of the multiple choice questions. So question 13 says that we have a locomotive of mass 6.5 times 10 to the 4 kilograms and of length 10 meters. I'm asked how long will a scale model be if it's of mass 1 kilogram. So what we're going to think about in this is how our length, volume and area scale factors relate. Well, what we know is that if the length scale factor is x, then the area scale factor is x squared, and the volume scale factor is x cubed. Now, we know that mass is density times volume, i.e. mass is proportional to volume. So this means if the volume scales as x cubed, the mass will also scale as x cubed. So what is our mass ratio? Well, clearly we've gone from 1 kilogram to 6.5 times 10 to the 4 kilograms. So that means that x cubed is going to be equal to 6.5 times 10 to the 4. Well, cube reason that, well, we see it's approximately 6.4 times 10 to the 4. So this implies x is approximately equal to 40. That's our scale factor from small to large. So that means our scale factor from large to small is going to be 1 over 40, which is equal to 0.025. So we see that our length will have to be 10 meters times the scaling down factor 0.025 to give us 0.25 meters, i.e. 25 centimeters. So we see that our length is approximately equal to 25 centimeters. Okay, so question 14 says we have a cylinder of volume 0.02 cubic meters and it contains 88 grams of carbon dioxide at 27 degrees Celsius. What is the gas pressure? And we're told that the gas constant R is 8.3 joules per Kelvin per mole. Well, clearly we're going to have to start with our ideal gas equation, PV equals nRT, and think about the constants we know and don't know. Well, pressure we clearly don't know. We're trying to find that out. Our volume, we always consider this in cubic meters, and this is going to be, as we're told, 0.02. R we're told is 8.3. Now our temperature, we know temperature has to be in Kelvin, and we're giving it in degrees Celsius. So Kelvin is 273 plus degrees. So Kelvin equals degrees Celsius plus 273. So 27 plus 273 gives us 300 Kelvin. Now what the number of moles? Well, how much does 1 mole of CO2 weigh? Well, carbon has molar mass of 12 grams, and oxygen has molar mass of 16 grams. So CO2 has an MR, a molar mass of, well, 12 plus 2 times 16. 12 plus 32, 44 grams. So we can read off clearly that we have 2 moles in 88 grams. So we can sub this in. So therefore, we know P is nRT over the volume, which is 2 times 8.3 times 300 over 0.02. Well, 2 divided by 0.02 is 100. So that's 100 times 8.3 times 300, which is equal to 830 times 300, which comes out to 249,000. i.e. 249 kilopascals. So question 15, we're told that a car battery delivers 160 volts at 100 amps, and the car is travelling at a speed of 36 kilometers per hour. And we're told the engine's 100% efficient. And we're asked, what is the force of air resistance? Well, this could be quite surprising. How do these quantities relate? Well, let's start by writing down what we know. We know, first of all, that power is, well, we're given current and voltage. We think about electricity, so we know that P is IV. That's one equation we know. We also know that power is force times velocity if there's a constant force produced and it's travelling at a speed of velocity v. Well, we have velocity and we want a force, so we have a current, we have a voltage, so this seems like the right thing to do. So this tells us that I voltage is equal to force times velocity. Okay, well, let's use this. So therefore we see our force So this is the force, the driving force of the engine. And clearly if the car is travelling at a constant speed, we know from Newton's law that there's no net force acting on the object. So if the engine is producing a force of F, then the resistive forces, in this case air resistance, must also produce a force of F in the opposite direction. So we can find F, we found the force of air resistance. So F is our current times our voltage over our velocity. Well, we want our velocity to be in the right units, and it's given in 36 kilometers per hour. Well, first of all, that's 36,000 meters per hour. But how much is that per second? Well, that means obviously you have to divide it by 60 times 60 to divide it by the number of seconds in an hour. So 36,000 divided by 60 times 60. Well, that's 36,000 divided by 3,600, which is 10 meters per second. So this is going to be equal to current 160 volts, times the current 100 amps over the velocity 10. That comes out to 160 times 10, which is 1,600 newtons. So question 16 says we have a cube that's painted all over and then split into 125 equally sized cubes. And we're asked how many of these cubes have no paint on them. So I've quickly mocked up a sketch of what this cube would look like, imagining that these are all the same size. And the reason I know it's 5 by 5 by 5 is because 125 is 5 cubes. So we obviously know it's going to be 5 wide by 5 high by 5 deep. Let's try and think about what cubes are going to have no painting on them. Well, let's just imagine for now we're only considering the looking at it in this direction here. So let's imagine we're thinking about which cubes. I'm going to ignore the front face here and the back face. We're thinking about which cubes are not painted on any of the top 1, 2 sides and bottom faces. The 1, 2, 3, 4 faces. So the bottom one, not the one pointed, the one below, the one you can't see. The side one here, the other side one you can't see, and the top one. So which cubes haven't got any paint on that side? Well, clearly we have to disregard any cube that is on the edge, that has an edge facing this side. So we have to ignore this line, ignore this line, ignore this line, and ignore this line. So that leaves us with, well, just simply these 3 by 3, this 3 by 3 block here. So draw an outline of that to make it more obvious. So we're left with this. So currently we have a 3 by 3 block that's 5 deep. But now let's think about the other. Let's think about now which ones aren't going to be painted on this front face and this back face. Well, clearly, again, we have to ignore the side that's painted on here. So now we're ignoring this entire side. So we're ignoring all of these ones. So what we're left with now is a 3 by 3 here. So what we have, well, in fact, we're left with a 3 by 3 by 3 block. So that gives us a total amount of 3 by 3 by 3, 27.